Hello students, welcome to Edubbey Global Solution, and under our mathematics class we're going to be looking at how to sketch our graph functions, and here we're going to be calculating gradients of lines. When we have a straight line, how can we calculate its gradients? And when we have a curved line, like when we're having a parabola shape, hyperbola shape, how do we calculate its gradient? So we have our interactive class here that will serve as a guide for this class. Okay, the gradient of a straight line is constant and is calculated by considering the coordinates of 2 points on the line, which is what? X and Y. So the gradient of a straight line is calculated by change in Y divided by change in X. That is the change in Y axis divided by change in X axis, which is Y2 minus Y1 divided by X2 minus X1. Now we have a work example. Look at this graph here. We have an illustration here, and if you look at that graph, we have 2 values for Y and 2 values for X. So this is the change in Y, and we are dividing it by what? Change in X. Okay, so let's cite what we have here. So for this graph, we have our Y2 and X2 to be what? 4, right? And X1, Y1 to be what? 0, and we have 2. So for this graph now, our Y2 is going to be taking of value of 4, Y1 also is going to be 4, X1 is 0 here, and Y1 is 2. So let's go ahead and let's calculate with the formula, which is the gradient of a straight line, which is change in Y divided by what? Change in X. So what is Y2 here? Y2 is 4, so Y4 minus, what is Y1? 2. Okay, divided by what? What is X2? X2 here is what? X2 is 4, and what is X1? X1 is 0, minus 0. So 4 minus 2 will give us what? 2. 4 minus 0 is 4, so that is what? 2, 1 divided by 2, that is 2 can go in 2 how many times? 1, and 2 can go in 4 how many times? That is 2 times. And that will lead us to how you can actually drag the right answer to the boxes. So the gradient of a line, of a straight line, the formula is Y2 minus Y1 divided by S2 minus S1. So we have said that our Y2 is what? 4, Y1 is 2, S2 is 4, and X1 is 0. So having doing that, 4 minus 2 will give us 2, and 4 minus 0 will give us what? 4. So how many times can 2 go into 1, and 2 can go in 4? How many times? 2. So let's check the arrangement. Okay, now let's look at the gradient of a curve. When you have a curve in the sense that you have a gradient, a quadratic function, or we have a cubic function, how do we go about calculating the gradient of such function? The gradient of a curve is not constant. It is slope change and calculate at a specific point with the following step. So how do we calculate the gradient of a curve? So the first thing we have to do is what? We draw a tangent of the curve at that point. Then we calculate the gradient of the tangent. You have an illustration here. This is a curve, and now for us to get it, what do? We draw a line at this point here, and we calculate the gradient where it meets on the x-axis and where it meets on the y-axis. So let's look at the work example that we have here, and let's go for the function y equals to 2x raised to power 2. We have to calculate the gradient of the curve at point where our x equals 1. So where x equals 1, this is the point where x equals 1. So we trace it here, and we draw the line up and locate the y-axis and the x-axis. So from here now, we have our x2, y2, x2, y2 to be what? That is 3, 10, right? And x1 and y1 from the graph is what? 0 minus 2. So, and based on the formula for gradient of a curve, we have y2 minus y1 divided by x2 minus x1. Now, from here, what is y2? Y2 is 10, right? And y1 is what? Minus. So we have minus and we have minus 2, okay? Now, what is x2? From there, x2 is 3. And what is x1? x1 is what? 0. Okay, so we have minus minus will give us what? Plus. Minus times minus will give us plus. So we have 10 plus 2 divided by 3 minus 0 will give us what? 3. 10 plus 2 is what? 12, right? 12 divided by 3. How many times can 3 goes in 12? 3 can go in 12 4 times. So at point when x equals to 1, the gradient of the curve is 4. So let's drag in the right answers to the boxes. 10 minus 2 will give us what? 12, right? Okay. 3 minus 0. Okay, so that would be what? That would be 12 divided by 3. How many times 3 goes in 12? That is 4. So we have 4 as our final answer, and that gives us the solution to that problem. Now let's look at sketching a linear graph. A straight line graph can be sketched by working out where the line intersects both axes. So if we have to sketch a straight line graph, what we just need to look for is we look at the line where both graphs intersect both axes. So now you have an example here. We have to sketch the graph y equals to minus 3 plus 5. So what happens? So for this one, I see that we don't have any specific point for y and we don't have specific for x. So what we just need to do here, we set an arbitrary point for x and y, which is 0 on our graph. You know, we have a specific point of the graph. Let's look at this. This point here, we have our y to be 0 and our x will be 0. So now having that, we place it inside this equation. When y is 0, what is x? We calculate. When x is 0, what is y? We calculate. Then that will now give us the opportunity to sketch a straight line graph. So yeah, let's look up for the very first one when x is 0. So we have y equals to minus 3. Wherever we see x now, we place 0. So plus 5. Minus 3 times 0 will give us what? That is 0. So 0 plus 5 will give us what? 0 plus 5 will give us 5. So when x is 0, y will give us 5, right? Now let's sketch the next one. When y is 0, what is y? What is x? So we have 0 equals to minus 3x plus 5. That is the given equation that we are solving. Now since x is 0, we need to bring y is 0. We need to bring minus 3x to the other side. So it changes towards plus 3x. We have 3x equals 5. We are looking for what? 3x. So we divide both sides by 3. So x will give us 5 over 3. 5 over 3 is what? 1.6. That is in decimal point. Now 3 above 10 implies that many times can 3 goes in 5 and 1 is the remainder. You raise it to 0 and you have 6. Okay. So if you want to sketch this graph now, we can now have our y-axis and our x-axis. What is the value for the y-axis? We are told that when x is 0, y is 0. Okay. So now the next one is when y is 5. That y is 5. X is what? X is what? 1.6. This is our x-axis, and this is our what? Our y-axis. Now, when y is 5, x is 1.6. So we sketch a straight line to meet the point, and that is how we sketch a straight line graph. So quickly, let's drag the right answers to what we have here. So minus 3 plus 5, that is 0 plus what? 0 plus 5, right? So if you have 0 plus 5, now when you divide through, when x is then we have 3 should be 5 over 3, and 5 over 3 will give us what? 5 over 3 will give us 1.6. Remember that we said that y will give us 5 here, because 0 plus 5 will give us 5. Okay, now let's look at the next activities, which is sketching quadratic function. With a quadratic function, the sketch should be a smooth parabola shape. And we have an illustration here. This is how a quadratic graph looks like. So let's look at the example that we have here. We have an example here. We have to sketch the graph of x raised to power 2 minus 8x plus 5 equals 0. So now what we need to do is we equate the equation to y and solve for x. And the very first thing that we can do here is to factorize. If you look at this type of equation, we can use factorization method. We've solved that before. When you are factorizing, you are looking at the coefficient of b, two values that you think that you can add together that will give us the coefficient of b, and by two values that you multiply together that give us the coefficient of c. So here now, what are the two values that you multiply together that will give us 15, and by the time you add it together will give us minus 8, and that is what? That is minus 3 and minus 5. Now having minus 3 minus 5, we replace minus 8 here with what? Minus 3x and minus 5x. Then we factorize the common numbers out. So we have x squared minus 3x minus 5x plus 15 equals 0. So let's factorize by putting them in pair. Okay, so what is common here? X. So we have x minus 3 left here and minus 5. 5 is common in 5. 5 can go in 15. So we have 5 outside. S is left here. If 5 goes in 15, what's the remainder? That is 3. So we have okay, 3. But remember, we have minus outside the bracket. So minus times plus will give us what? Minus. So this changes to minus and we have 3 equals 0. If you look at it, we have a common term inside the bracket. So we bring one of them out. We have x minus 3 and x minus 5 equals 0. So when x is minus 3, x minus 3 equals 0. By the time x crosses to the other side, it changes to what? X equals to 3. And when x is minus 5 equals 0, x changes, minus 5 changes to what? Plus 5 by the time it crosses it equals to sign. So x equals what? 5. So the value for x ranges at x equals 3 or x equals 5. Now, the next thing we've done here is what we have to calculate the minimum point. How do you calculate minimum point? After you sketch your graph, you look at the midpoint of the value of x axis. Now, let's sketch our graph. We have something like this. Let's quickly sketch. We have the highest value that we can have for y is what? 15. We have x to be 1. We can have 1, 2, 3, 4, 5. We can have 6 and the code. So under this one, the solution for that graph is what? We have when x equals to 3 and when equals to x equals to 5. So all we just need to do is we are drawing the parabola shape on this line. Now, if you look at it, 3 and 5, the midpoint is what? 4. So having that midpoint, then we have x equals to 4 and we put it to this equation to get our minimum point. So we can now have our expression to be y equals to x raised to power 2, okay, minus 8x, that is the original equation, plus 15. Now, whenever we have x, now we are going to be replacing it with the minimum point, midpoint between 3 and 5, which is 4. So y will now be equals to 4 square, okay, minus 8 into bracket 4 plus 15. So 4 square will give us what? That is 4 times 4, which is 16, minus 8 times 4 is 32, plus 15. Minus 32 minus 16 minus 32 is what? Say minus 16 plus 15, that is minus 1. So for this one, the minimum point we can now have when x equals to 4, y equals to minus 1. And that is give us the solution to the function that we have there. Now we have how to sketch cubic functions. For a cubic function, that implies that x is going to be raised to the power of 3. So I can have it when we have one point of intersection, that is on this line here is just meeting only one point on x axis, and we have 2 points of intersection. If you look at it, the graph is meeting 2 points on x axis, and we have 3 points of intersection when the points on the x axis are actually 3 in number. We have 1, 2, and 3, and these are the likely ways by which we can actually plot a cubic function. Okay, now let's look at how we can sketch our reciprocal function. When we are talking about reciprocal is when you divide a given expression by 1. Now, for example, when we have x raised to power 2, by the time you divide x raised to power 2 by divide by 1, it's going to give us 1 over x raised to power 2. And the graph can be of this form, where you have the negative aspect of x and y axis and the positive aspect of x and y axis. So in this form, we have an illustration of when y equals to a over x, that is both the function that we are giving to us is a positive expression, and when we have a negative expression y equals to minus a over x, these are our graphs alternate each other. So the graph does not intersect either axis. As x increases, 1 over x gets smaller, and as 1 over x gets bigger, that is, as 1 over x increases, that is reciprocal of a function on the x axis, then it moves closer to the y axis. And we have another function here, which is exponential function. The exponential function takes the general form y equals to a raised to power x. Okay, the graph have different characteristics and shape. Now we have an illustration here when y equals 4 raised to power x, when y equals to 3 raised to power x, and when y equals to raised to power x. Now this is how the graph is going to be looking like. If you look at this graph here, there is a point, a coordinate point where x is 0 and y is 1. So if we are to sketch this type of graph, we are going to be having a specific point where x is equals to 0 and y equals to 1. And as it is going to be moving, higher and tending higher to infinity. This takes us to the end of our class on sketching graph functions. We want you to subscribe to our channel www.edubbey.com for the full interactive content of this class.